Hello, all. Let us talk about Faraday cage or Faraday shield in embedded systems. Faraday cage is nothing but a kind of enclosure which is used in electronics, which helps to protect the electronics from the EMI, whether the EMI that is generated from the boards that escapes out of the board, or whether the EMI that is generated in the surroundings, like example a nearby RF station, or basically a mobile phone or a computer. So whatever the sources of EMI are there around, so those kind of EMI are blocked by using this Faraday cage. Now this Faraday cage is also called a Faraday shield, and it helps us to protect the boards from EMI. So it is very important basically in the EMI MC certification, in helping in the EMI MC certification. And this Faraday cage basically is nothing but we can say it is a conductor because it is made out of metal. Most of the enclosures use aluminum. So this metal enclosure, it can vary in thickness, or it can vary in shape and size. So there are different dimensional variations of this Faraday cage, which we have to understand. Now if you see the board here, that is listed out on the right, you can see the holes that are there throughout the board. So these holes are nothing but vias, which generally would be grounded to this mounting hole, and we can say this also is a kind of Faraday cage, because it either eliminates radiation out of the board, or absorbs the radiation that comes from the external environment. While it helps in only certain ways, this is one type of Faraday cage which we can say is implemented on the PCB. Now this is a simple metal enclosure you see here, where it is basically off-the-shelf aluminum mechanical module that is available, where you can use it as an enclosure for your electronics. Now this particular metal enclosure can be called a Faraday cage, and this absorbs or restricts the EMI, whether it is to get out or get inside this. So now one question that embedded engineers definitely face is, should I ground this Faraday cage, or should I not connect it to any like a ground and leave it open, or should I connect power to this? So there are different options that you can use. So either of these options, all the three options, we can say that can act as a Faraday cage. Whether if it is left open also, it acts as a Faraday cage. If it is grounded also, it acts as a Faraday cage. Or if it is powered also, it acts as a Faraday cage. Now what's the difference between these three? One thing is that example, let us assume that we have left it open and we have not connected it to a earth terminal. Generally we connect this to earth, right? The enclosure. So in that scenario, if we have not we have just left it open and we have not connected it anywhere, there will be some static charge that will be like present across this enclosure, which causes the conductivity to happen, and there might be a chance that this static charge might leak onto your circuit, like how a ESD event can occur. So why does this static charge comes into picture? So what happens is, let us assume there is a PCB inside and there is a radiation from this PCB, or there is some radiation that is coming out to this enclosure to leak into the PCB. So there are two scenarios, right? When either of these happens, the radiation would be absorbed by this particular cage here, and this will get deposited as a electron charge, a static charge, and this static charge will be opposite to the charge actual source. So this charge cancels out, and finally there is zero leakage from this metal enclosure. Now this again depends on the frequencies as well. Basically we know that skin depth concept, so skin depth plays a major role here. If you have very higher frequencies, the signals would be restricted to a very high level of this enclosure, and they do not penetrate much, which is basically an advantage. But if there is a very low frequency field, like example Earth's magnetic field, because of the skin depth, it penetrates much deeper because of its low frequency, and there could be a chance that that could get inside to the enclosure. So now, because of these charges that we are talking here, this Faraday cage will definitely have some static charge that is deposited, and this static charge need to be taken care of. Now here what we are saying is when if the Faraday cage is left open, and if it's not earthed, now in that case what happens is the static charge might not have a path to leak, and this static charge may act as a ESD and cause failure to our electronic boards. Now there is one scenario like powering up this. Instead of opening it up, we will use the power, give it a power, which is not a real-time usable scenario, because if you give power to this, there is definitely a case of electrical shock that can happen if a low impedance path is arrived, or low impedance path comes in contact with this. So that is definitely ruled out, but still it acts as a Faraday cage, but safety concerns are an issue here. Now the third case is like grounded. So we have talked about the open scenario, the powered scenario, and the grounded scenario. So one of the most scenarios used common scenarios used in Faraday cages, where you have a PCB mounting holes which will be connected through metallic screws to this aluminum enclosure. So you can see here this slot, a metallic screw will be used to connect here, and the PCB earthing holes will be shorted to the enclosure. So now in this scenario, you will have a path for the static charges across this enclosure to skip from this, and definitely this is advantageous, and there is very less chance that your circuit shall be prone to any issues. So that is why you see any enclosure, especially the metallic enclosure. Plastic enclosure, you definitely don't have a option, because plastic enclosure doesn't conduct, and so metallic enclosure restricts this, and plastic enclosure, you will have issues of EMI EMC, because it just passes through without absorbing any content. So coming down to another scenario in Faraday cage, should a Faraday cage be a complete metal or perforated? So what is the difference between complete metal and perforation? Is that complete metal is like a full enclosure without any holes in it, whereas perforation is like the case you see here, where there are small holes within a cage. So in general scenario, if you have need of IP scenarios, so you will have a full enclosure, but if there is no IP need, you can have a perforated cage which will also save cost to some extent because the usage of metal would be less. So when can we use these perforated cages? So, and what are the use cases? So using metal case is the best scenario, but in case if you want to use a perforated shield for your devices, so these perforated shields basically are like small holes on the metal enclosure where the whole dimension, like example, if you see here, this is a small hole, the whole dimension determines the kind of wavelength that it can pass through. If the whole dimension is less than the wavelength of the signal that is coming onto this, the radiation that is coming onto this hole, then it will restrict. So you have to have holes for these perforated enclosures such that it is always less than the wavelength, such that they are restricted. If any signals come onto these cases where the wavelength is much lesser than the whole dimension, then they might leak onto this board. So perforated is a common scenario where industrial cases you use them regularly, but for electronic EMI EMC requirements, a full-fledged metal casing is the need of the requirement. So this is about Faraday cage. There are many topics related to this. Please post your comments, suggestions on this video. Please like and subscribe to our channel. Thank you.